Good afternoon, guys. Today I am going to explain for you the finding x and y intercepts for a log function. And I actually prepared the file, so I'm going to go over the steps that I did. So let me first of all share my screen with you and go over the Microsoft whiteboard. So I'm going to show you the very beginning of this question. So the question starting from here, guys, watch. The situation here, guys, if you take a look, I'm just going to show you that we have an example saying that y equals to 2 logarithm 3x minus 6 as an argument of the logarithm for the base 10 minus 3. So as you know, guys, from the simplest logarithm function is this function, which is, I will try to put it in a red rectangle here in for you guys. This is the function we have, so the original function, and the function with having all types of transformation, guys. I will also put it here, and then you can see, and I will read everything for you. Let's just make it this way here. Maybe I can do it this way. I don't know if this is going to be nice. So let me see. Yeah, it's not bad. Here we go. And or I can just redo that one more time. So let me just redo it, try to make it nicer without going through the other important things. Here we go. That's better. So this is the logarithmic functions with all type of transformation. A representing the vertical stretching factor. C is the base of the log, and B is representing horizontal stretching cause. It's not horizontal stretching factor, because as you know, the horizontal stretching factor is can be given as by 1 over b. So 1 over b, basically, if I just write it down here, if it's possible, 1 over absolute value of b, that's going to represent the horizontal stretching factor. So you have this. And now I'm going to mention that, or I can clean all of these to make the things easier. Maybe people can see that if I just clean this part here and make the mentioning the numbers. Here is 10, as you know. I'm just going to rewrite it again. And this is my minus 3, so I will put 10 in here. And that's my log. So you know, guys, that a is 2, and 10 here is going to represent the base c, and that's the base c. 3 is after I take the common factor between 3x and 6, then I'm going to divide 3x by 3 and 6 by 3. That's going to give me 2. 2 is actually the horizontal shift, and k, which is going to represent, as you see here, guys, it's going to represent the vertical shift or vertical translation. H is always horizontal shift or horizontal translation. So finding x and y intercept, guys, for this type of questions, we need to substitute. As you know, that for x intercept, we need to substitute y equals to 0. For y intercept, we need to substitute x equal to 0. So normally, for any log function, guys, I'm just going to put this inside a bracket or maybe a rectangle that we know. For any normal situation, if I have y equals to log of x for the base 10, so if we want to change that to the exponential form, so this is going to be equivalent, I'm going to write it down beside that, so this is going to be equivalent to a 10 to the power of y equals to x. That's why I made it 10 to the power of y is equal to x. That's the exponential form of the logarithmic function. I'm going to just also put this guy inside a rectangle. Okay, guys. So now by doing all of these, first of all, I am going to substitute y equals to 0. So I'm going to substitute that in the original function, and you can see I substituted equal to 0, y equals to 0 here. And now I have the negative 3, which is representing k. We'll move it to the other side, make it positive k, or positive 3. So nothing left on this side, only one term, which is 2 logarithm 3 times x minus 2, close the bracket, for the base 10 equals to 3. Now I am going to divide both sides by the coefficient of the log, and then this is the coefficient of the log, actually, guys. This is the coefficient of the log. That's why I'm dividing by, actually, I'm dividing by 10. So I divide by 2, sorry. When I divide by 2, so 3 divided by 2, 2 logarithm 3 times x minus 2 divided by 2, I cancel out 2. I got to this equation, guys, which is 1.5, equals 3 divided by 2 is 1.5, logarithm of 3x minus 2, all inside the bracket, for the base 10. Now, as I'm going to apply the exponential form, I say that 10 to the power of 1 and half, 10 to the power of 1 and half. Let me write down this 10 is in a bigger size so people can see that this is the base. So 10 to the power of 1 and half is equal to the argument, which is 3 times x minus 2 in a bracket. Now I am going to make the value of 10 to the power of 1.5 is approximately 31.6227. And I am going to multiply 3 times x and then 3 times negative 2. I actually distribute the multiplication over subtraction in this situation. I'm going to move the negative 6 to the other side, so I make it positive and add it to 31.6227. That's going to give me 37.6227 equals to 3x, or in another way, 3x equal to 37.6227. Divide both sides by 3. It's going to give me exactly the value of x, which is approximately 12.5409. And if I want to simplify that, so, or maybe approximate it more, so I will round it to the nearest thousandths. That's going to be 12.541. Now, I would like to share, guys, this graphing of this function using Desmos. And I'm going to share this with you. So this is the Desmos, guys, exactly. So you can see that I put all of the numbers here, and my vertical asymptote is x equal to 2. That's going to make this difficult or impossible to have y-intercept. But I'm still doing this y-intercept for you also, so you guys have the x-intercept exactly 12.5409 and 3, and that's my x-intercept. So if I go back, guys, stop sharing this maybe, and go back to my Microsoft whiteboard, I will share that with you guys. So now we are going to do the other part, which is, as we said here, that for y-intercept, we substitute x equal to 0. So let's do that, see what's happening. And this is going to be a logic thing. So for y-intercept, and I'm going to write down here, as you see, I will put for y-intercept, I'm going to write down y-intercept is intercept here is how to substitute x equal to, or we can say that I would like to say substitute. So let's write down here, substitute x equal to 0. The function we had was y equals to 2 logarithm of a 3x minus 2 for the base 10 and minus 3. So now I'm going to substitute x equal to 0 in this function, guys. When I do that, I will see that y is equal to 2 logarithm of 3, 0 minus 2, bracket for the base 10, and there is minus 3 in here. So guys, when I say 0 minus 2, it's going to be minus 2. So this leads to that my y equals to 2 logarithm of 3 times minus 2 for the base 10, and there is minus 3 in here. So guys, you can see here that we cannot find the y-intercept because the argument of the log became negative, and this is not acceptable. It's out of a domain. We can't accept any domain or any argument of any logarithm or argument for a logarithm for any base to be negative. So there is, we will say here, there is no y-intercept. And you could see that, guys, you could see that in the function. If I share back, my function with you. So I'm going to share back the Desmos. You can see that easily. You can see that there is, even if I make it bigger, so you can see that the vertical asymptote is not allowing even to pass number 2 because it's going through 2. The vertical asymptote is going through 2 and 0. And we can label this point also if you want. So that's the situation. So you can see, guys, that it's an easy way of having this type of function. This function is basically shifted to the right by approximately 2 units, or exactly 2 units. That's why we can see that the x-intercept has been shifted several units to the right, instead of having x-intercept at 1 and 0 for the normal situation. I can show you guys if I clean this. Watch here, guys. Let me clean all of this, or maybe I can just write down here in the bottom another function, which is y equals to logarithm of x, and without anything. So you can see clearly that the x-intercept is actually 1 and 0, but the x-intercept has been shifted 12.5409 to the right, because that your vertical asymptote is just 2. So everything has been shifted, and then you can see that even in the situation, guys, of this situation, when y equals to logarithm of x, you can see that the vertical asymptote now is y-axis, which is, we know that the equation of y-axis is just x equal to 0. Equation of y-axis is x equal to 0. This is, guys, one of the function. I would like to give you another one. Now let's go back to the Microsoft Whiteboard, and I take another example, or maybe the same example, just changing. Watch here, guys. We'll take the same example. I had it before, just changing 3x minus 6. I'm going to make it 3x plus 6, and I keep everything else as it is. And now we may have both x-intercept and y-intercept. So I'm going to write down that for you. I know that the video is going to be a little bit longer, so hopefully I will not make it very much long, because it's people getting bored when we have that. So I'm going to say that y equals to 2 logarithm. Now I will make it a 3x plus 6. We close the bracket for the base 10 and minus 3. Now again, we try to find, first of all, x-intercept. So finding x-intercept, as we know, is the reason that we need to substitute y equals to 0 for the x-intercept. So I'm going to do that for you guys. You can see that easily. So I put, instead of y 0, and I put 2, and I will say logarithm of a 3. I can take a common factor also here, and I close the bracket, so the base is 10. So now I am trying to move. Now I am going to move. I would like to move this 3 to the other side. So let's move the 3 to the other side. Let's just take this one here and move the 3 to the other side. So this -3 is going to be moved to this side, guys. That's going to give me a positive 3. Well, we have a 3 equals to a logarithm, 2 logarithm of a 3 bracket x plus 2, close the bracket, for the base 10. Now, as we did in the previous example, we divide both sides by 2, so we get 1.5, and the 2 is going to disappear here, so we have a logarithm of a 3 times x plus 2, and the base is 10. Again, guys, we do the same situation we did in the previous example. We say that this is going to lead to that 10 to the power, I'm going to just show you that, 10 to the power of 1.5, which is represented. Now, this is going to be the power of 10. That's going to give me the entire argument, which is everything here. You see that, guys? You can see that. So 10 to the power of 1.5, and we know the value of 10 to the power of 1.5 from the first part of this question. It's going to give me a 3 times x plus 2. Again, guys, this is going to give me the answer Now the answer is going to be a little bit different, but let's see what's happening here. So we said that the 10 to the power of 1.5 is going to give me 31.6227 from the previous one. That's going to give me a 3x plus 6. Now I am going to move 6 from this side to the other side, and that's going to be minus. So I'm going to subtract from 31, which is, if I use my calculator, guys, I would like to subtract from 31.6227, I subtract 6 from that. That's going to give me 25.6227. So I'll share that with you guys, 25.6227. Just be careful. That's a 3x, or in another word, we say that 3x equals to a 25.6227. Now we divide both sides, as you know, by a 3. So we divide this by 3 after we subtract the 6 from that, which is because 3 is the coefficient of x, so the answer is going to be 4x, guys, in here. That's going to give me 8.5409. So here, the x-intercept in this situation, guys, that's an x-intercept for this situation, is actually 8.5409. Let me just write it down in a nicer way, 09 in here. And of course, y is 0. This is x-intercept. We got x-intercept here, guys. Do you see that? That's x-intercept here. I'm just going to make it a little bit colorful. And then now we are trying to find y-intercept. And now in y-intercept for this function, I'm going down a little bit. I'll write the function as it is. So we have the function now y equals to 2 logarithm of a 3 times x plus, let's make it a little bit nicer. And this is a 3 bracket x plus 2, and then for the base 10, of course. So for y-intercept, guys, as you know, for y-intercept, what are we going to do? We substitute x equals to 0. We substitute x equal to 0. So let's see what's happening if we substitute x equal to 0 in this function and find the y-intercept. So I'm going to rewrite that y equals to 2 and logarithm of a 3 times 0 plus 2, and I close this bracket, minus 3 for the base 10. Now we try to simplify, guys. We try to simplify everything. So I'm going to show you guys what's happening here. Y is equal to, so 2 logarithm of, well, 0 plus 2 is 2 times 3 is going to be 6. That's going to give me a logarithm of 6 for the base 10, and outside I have a negative 3. So I need to simplify this as much as possible. As you know, guys, from one of the law of logarithm, that, and I'm going to show you that law, it is a power law. So from the power law, guys, as you know, from the power law, if I have a logarithm of x to the power of n for the base c, I can rewrite it as an n multiplied by logarithm of x for the power of, for the base of c. So this power n is going to be multiplied behind the logs. It's going to be a coefficient of the log. This is one of the law of logarithm, guys. One of the law of logarithm, we know that very much. So I'm going to put this 2 on top of the 6 in here, guys. I can do that. And I will rewrite that and see what's happening, what's the situation after that. So I will show you this. So y equals to logarithm of 6 to the power of 2 for the base 10. Well, and there is minus 3 here. I prefer to put the argument inside the bracket. So this is logarithm of 36, guys. Watch here. Logarithm of a 36 for the base 10 minus 3. We need to find that. Use the calculator to find logarithm of 36. So let's see how much is the logarithm of 36 for the base 10. So if I just say log of 36 and I close the bracket, So that's going to give me 1.55. So that's going to give me 1.556 basically. So logarithm of 36 for the base 10 is 1.556. And I'm going to subtract 3 from that. So if I subtract 3 from this one here, that's going to give me approximately, if I go down, approximately y is equal to negative 1.4436. So I have now the y-intercept, which is x equal to 0, and my y is negative 1.4436. I can show you this function also, guys. Let me just put it inside the bracket in this one here. So I have now in for this function, because my function has been shifted to the left, for this function I have y-intercept and I also have x-intercept. So this is x-intercept. I would like to put this one also inside a rectangle. So for the second function, which is, as you see here, it is y equals to logarithm of 3x plus 6 for the base 10 minus 3, that there is y-intercept and x-intercept. Let's now move to Mr. Desmos, the website we have always try to use this website, but let me just, guys, put this one down so you can see the last two things we did together. And this is the x-intercept and y-intercept. And I can also color this one here. So you can see that we have both, in this situation, we have both x-intercept and y-intercept. I'm going to show you that by using the graphing calculator Desmos. So I'm sharing my screen one more time to make it easy for you guys. I know that this is going to take a little bit longer time, but let's do that. Let's clean everything we have here. And I'm going to clean all of these and clean this, clean that, clean this one. I'm just going to change, guys. Let me show you that this will be only positive, guys. Look at this. This is going to be positive. So clearly, guys, you can see, look at the x-intercept. We have x-intercept. You can see that clearly. Very nice. X-intercept is 8.5409. That's what we got. And now we have also y-intercept. So look at the y-intercept. The y-intercept is also the same number we got from our work. Now, the only thing we are missing, or if you want me to compare that, because after we write down this y equals to, let's say, 2 logarithm of bracket, let's make it 3x plus, or maybe I can take 3 as a common factor, and then x plus 2, close the bracket, and then minus 3, which is the same. One is going to show you as a blue one instead of having red. Now, we know that we have, our function has been shifted 2 units to the left. So I can say that x equals to negative 2. That's my vertical asymptote. So you can see clearly, guys, watch here. Now we have both x-intercept and y-intercept. Because the function has been shifted to the left by 2 units, we have both x-intercepts and y-intercept. This is, guys, 2 examples. One of them, the function has been shifted 2 units to the right. There is no y-intercept. There's only x-intercept. And the other example is the function shifted 2 units to the left. So there's x-intercepts and y-intercept. Basic information, guys, as you know, if I go back to my normal work with Microsoft Whiteboard, and I share my screen with you one more time, you can see, guys, the one which is I always tell my students to remember, that when we have any function, try to, well, this is a little bit good work here. We started from this function. The only thing we changed it from the first example to the second example, that this sign here, this sign was in the beginning was minus. Do you see the sign? And for the next example, so we had, as you see, that we have x-intercept, but we don't have y-intercept. There is no y-intercept, and then we took another function here, just changing this to the sign from the minus to plus, and now, sorry, it's just, and now we can find the x-intercept, which was 8.5409, and as well as the y-intercept. So both of them can be founded together. Don't forget, guys, every time when you substitute to find x-intercept, you need to substitute y equal to 0, and when you want to find y-intercept, you need to substitute x equal to 0. Checking your work is very important, guys. So when you do the algebraic things, you need to know that it is better to show that with Desmos. Desmos is the best website we can use to check ourselves if we did everything right, and that's exactly the two questions we solved. This one is the part 2 of the question. So you got y-intercept and you got x-intercept. I just want to show you something. Some people asked me what happened if I change this positive 2 to something bigger in the beginning. I can do that for you guys. So I'm going to keep write down the same function in here, just showing you that, and we'll write down this function for you, and making it y equals to, instead of 2, I'm going to put 5, for example. 5 logarithm of same thing. I have a 3x, or 3 bracket x plus 6 bracket minus 3, and that's going to be like this. So you see, guys, as much as the vertical stretching factor is getting bigger, look at this now. We both have y-intercept, which is became positive, and x-intercept became negative. Now you can see, sorry, now I think I did a mistake here. When we take this between, that's not going to be 6, that's going to be 2. Sorry for that, guys. I just want to show you this. Just give me a second, guys. So I'm just going to make things easier for you. And having this, yes, you can see that now we have x-intercept became negative, guys. You see that? And y-intercept became positive. You can put these 2 points and make them, label them. Look at this, guys. I put this point here, I label that. So now when I changed the value of the vertical stretching factor, I can cancel all of these, guys. You can see that. Let me just cancel, so make things easier for you to watch, and just showing you these 2 points, which is, we have them here. And then I will label this guy and label the other one here, so you can see that the difference between them. There we go. So this is when I change the, let me just label this one also. When I change the vertical stretching factor to 5, my function has been shifted upward, and my y-intercept became positive while my x-intercept became negative. Do you see that, guys? I still have, for both situations, you can see for both situations, same vertical asymptote x equals to -2. X equal to -2 for both of them, guys. Same thing, because the first function, well, this function, even if I want to put a bracket here, just for your information, and I put another bracket here, when I take the common factor, so that's going to be the same. Watch here, guys. This is the functions. Having bigger vertical stretching factor is going to shift my function upward. So my y-intercept became positive, while my x-intercept became negative. In the beginning, I had my x-intercept positive and y-intercept negative. That's all because of the vertical stretching factor from 2 to 5. Thank you so much, guys, for having me in this video. And I know that this video was a little bit longer than the other videos we had on my channel. And then I really appreciate your time and watching all of my videos. Thank you so much, and I wish you a wonderful evening, and see you in the next video with more questions about the applications of logarithm in physics and chemistry, and even in normal life. Thank you so much one more time. Have a nice night.